In this substitution example, given that a is equal to 4, b is equal to -3, and c is equal to 12, calculate the value of a squared times 2b minus c. My first step is to substitute the numbers for the algebraic symbols in the algebraic expression. So, a squared, which is 4 squared, times 2b, which is 2 times -3, minus c, which is minus 12. Simplifying, 4 squared, that is equal to 16. 2 times -3, that is equal to -6. Minus 12, of course, is minus 12. 16 is multiplied by -6 minus 12, that is equal to -18. And finally, 16 times -18 is -288. And that is my answer. Next example. Given that m is equal to -3, n is equal to 2, and p is equal to -1, find the value of m times p minus n all squared over 3p plus m. Well, my first step is to substitute the numbers for the algebraic symbols in the algebraic expression. So, m is -3 times p, which is -1, minus n, which is 2, all squared over 3p, which is -1, plus m, which is -3. Here I'm going to be simplifying my numerator and denominators. So, -3, -1, minus 2, all squared, over -1 times 3, that is -3, plus -3, which is minus 3. Simplifying further, so I have -3 times -3 all squared over -3 minus 3, that is equal to -6. So I have -3 times -3 all squared, that is equal to 9 over -6. At this point, I notice that I have -3 in my numerator and -6 in my denominator. -3 is a factor of -6. So I can simplify this fraction. -3 into -3, that is equal to 1. And -3 into -6, that is equal to 2. So I get 9 on 2. I can simplify this improper fraction further and put it into a mixed number. I see 2 into 9, that is equal to 4, for a remainder of 1 on 2. And that is my answer. In this example, given that 4p squared minus 4q squared is equal to 2r, and that p plus q is equal to r, show that p minus q is equal to a half. Well, my first step is to write down my algebraic equation. 4p squared minus 4q squared is equal to 2r. I notice that I have 4, which is a squared number. I can rewrite 4 as 2 squared times p squared minus 2 squared times q squared is equal to 2r. All the terms on the left-hand side of my equation are squared. So I can rewrite this as 2p minus 2q all squared is equal to 2r. In this form, 2p minus 2q all squared, I can rewrite this using the difference of squares. So 2p minus 2q times 2p plus 2q is equal to 2r. Here I notice that I have 2 as a coefficient of each term on my left-hand side, so I'm going to factor out the 2. So 2 times p minus q times 2, factor out the 2, p plus q is equal to 2r. Recall, p plus q is equal to r. So I have 2 times p minus q times 2 p plus q, r is equal to 2r. Simplifying further, 2 times p minus q is equal to 2r divided by 2r. Of course, 2 times p minus q is equal to 2r divided by 2r, that is equal to 1. So I'm therefore left with p minus q is equal to 1 on 2. And that is my answer. In this example, find the value of p if 3 is a root of 5x squared minus px minus 18 is equal to 0. Well, if 3 is a root, we know that x is equal to 3. We can rewrite into root form. So x minus 3 is equal to 0. We can also rewrite the quadratic equation into root form. So we have x minus 3 times ax plus b, and we use the algebraic symbols a and b here because we don't know the second root of the quadratic equation, and that is equal to 5x squared minus px minus 18. Well, using the distributive property, I can expand the left-hand side of my equal sign. So x times ax, that is equal to ax squared. X times b is equal to bx. Minus 3 times ax is equal to minus 3ax. And minus 3 times b is equal to minus 3b. And that is equal to 5x squared minus px minus 18. At this point, I can identify which terms are equal. I know ax squared is equal to my 5x squared. These are the two x squared terms. And bx minus 3ax is equal to minus px. These are the x terms. And minus 3b is equal to negative 18. These are the constant terms. We'll let this be equation 1, equation 2, and equation 3. Using equation 1 to find ax squared is equal to 5x squared. Therefore, a is equal to 5x squared over x squared. A is equal to 5. Using equation 3 to find b, minus 3b is equal to minus 18. b is equal to minus 18 divided by minus 3. Therefore, b is equal to 6. Using equation 2 to find p, bx minus 3ax is equal to negative px. Substitute a is equal to 5 and b is equal to 6. So we get 6x minus 3 times 5x is equal to negative px. 6x minus 15x is equal to negative px. Negative px is equal to negative 9x. Therefore, p is equal to negative 9x over negative x is equal to 9. And that is our answer.